So far, we've been saving the graph in local storage and regenerating everything based on that when the page loads. But in this way, we lose the markings. Also, we can't save multiple worlds like this. And the trees appear randomly. And maybe you don't want that. Not to mention that the worlds can be quite big, and generating them when the page loads can be time-consuming. You'll see when we work with real-world data, I'm not patient enough to draw such a large graph now. So I think that having a way to store the information in actual world files and loading them afterwards is a must. You'll see it really saves the day. Get it? Saves the day? Because we're gonna say that no.
Gonna code, debug, and have fun. Coding with Radu. Coding with Radu. Gonna prototype and design. Coding with Radu. Coding with Radu. Let's code now.
Done. Now you have a nice world like this, and you want to store it, save it somehow, with everything, all the markings, everything. We'll do that using local storage as well. So we're gonna store here as the world item, stringify the world. It's now here if we type get item world, all the information is here from absolutely everything. So I shouldn't lose all the things that I have here. But of course, we need to add this functionality to the save button as well. So let's do that. Inside the save function here, instead of saving the graph, we're going to save the world. And loading the world when the application starts, it's going to be pretty similar to what we have done here by loading the graph, but we replace these. So world string is what comes from world, and then world info, we take here world string, like so. And now I'm going to keep this for reference. But the way we define the world and the graph is going to be a little opposite way. So first, the world is going to come from world info if it exists. Then world is going to load from world info in the same way we were loading the graph earlier. And otherwise, define a new world with an empty graph like this. So now this graph is going to come from the world instead. And we don't need this code anymore. Now, world load, this is what we're going to do today. Focus on how to load the information stored there as a JSON string. So let's go and open world.js. And just below the constructor, I'm going to implement here a static method called load with the info, and then just return a new world where we load the graph from the info graph like this. This is the quickest thing that we could do and get something that actually works. Now, if I go back here and refresh, you're going to see the shape is still here, but the markings are not there. And also, every time we refresh, the trees are a little bit different. So that's something that I don't really like. Maybe we want to keep the tree locations so that everything is exactly as we know it. And the markings, of course, are gone. And one more issue with this implementation is that now we do call the world constructor, which calls generate. And this does a lot of work. Really a lot of work. For big maps, this can take even minutes. And you'll see that later when we work with real-world data. But basically, when we load this, it shouldn't need to generate anything. We should just be able to restore all the generated items from this information. And that's what we are going to do next. So let's begin here by defining an empty world first, one that does call generate, but since the graph is empty, there's nothing there really. And then start populating the items. So the graph, this first item right here, this one is going to come from loading the graph from the information like that. And here we just return this world that only contains the graph at the moment. Save and refresh, and now we get this. And this is okay, the world just shows the graph because the other things are empty. So envelopes, road borders, buildings, these are not there, not yet at least. And we're going to need to populate them. Also, these properties should come from our local storage. But one thing that you should note is that when I drag this, things start appearing again because the generate starts to function again. The generate from here inside of animate, when the graph changes, the world does regenerate based on the graph. So just for you to know that this is expected behavior. So let's begin by taking all of these attributes now from the info here. So this world is also going to get the road width, roundness, building width, minimum length, spacing, and the tree size from the info. In case we want to generate roads with different properties here, then they will come from the local storage. And now we proceed to generate these envelopes. And the way we do that is the same way we did for the graph, this load method. We have to implement load methods for the envelopes as well and make them proper objects, not just raw information from this info here. So I'm going to say that the world envelopes are going to be coming from the info envelopes, which are just info, not actual envelopes, where we map them so that each element E is going to be envelope load that information. Now we go to the envelope primitive here, and we have to implement a load for it, because this generate polygon is also quite an expensive function, and I don't want to just call envelope with that information, the skeleton for example, and regenerate it. I'm going to implement here a way to create an empty envelope, one that if we don't pass a skeleton, then none of these happen. And our static function for loading is just going to get the information and generate an empty envelope. It will have the type of object envelope, and it will have, for example, the draw and this other method in it. But then the skeleton of this envelope is just going to come from the info by generating a new skeleton from the P1 and P2 of info skeleton, like this. Now, technically, these should be also cast as points, but I think it's going to be okay. And then the poly, we have to add a polygon load method from this info poly. And now we can return this envelope like so. And the polygon load method here at the top, a static load. Given the info, I'm going to return a new polygon from these info points, but I am mapping them now to actual point objects. This is important, otherwise some errors will come. Now save, refresh, And I have some errors here because I accidentally forgot to remove this. I wanted to replace this with world previously, and I made a mistake. Save and refresh, and now the envelopes are showing as well. Now, the next thing here in line is the road borders. This is not so demanding because they are just segments. So road borders is road borders map each border to a new segment, P1 and P2. And again, I don't bother casting these as points. We don't call any methods of those points in our code. So I just save some time by not doing it. But the proper implementation would have that cast also here. And maybe segment endpoint should have also this load functionality there. That would be the most proper. But I'm starting to want to end this so I can focus on phase 3. Now here the buildings are next. Let's write here world buildings, info buildings, map, new building by loading it. We have to do this here, but it's straightforward. So in our building item here, just give it a static method that loads this info. And we return a new building this time by loading the polygon of the info base. And here we have to specify the height as well so that the building remembers its height from the original info. We didn't really play with different heights or anything like that, but this makes the code more proper. Let's save and refresh. And now the buildings are there as well without the need to generate them. Next, we have the trees. Let's do something also here. I'm just going to go through each tree and generate a new tree here. I don't think it needs any load because the processing that happens for trees is actually in the draw. So if I open here tree.js, this generate level is called here while drawing, and all we need to do here really is initialize this. Generating the first is just creating a single poly, basically, so not much trouble to just re-initialize the trees. Trees can be quite problematic in the generation process because here generate takes a lot of effort for the trees. If you remember, we had this while loop here that tries to add a lot of trees, and it's going to try again and again and again and then reset and again. But now we are going to tell here which locations to use. So that part is gone. And if we refresh now, we'll actually see that every time we refresh, the trees are going to be at the same locations, always. Because now there's no more randomness at play when loading this world from local storage. Now, for the markings to work, we also need those lane guides. They are next in line here, actually. So let's take the lane guides as well. Lane guides. We map them to new segments with the same points. And now the only thing left are these markings here. And this will be a problem. Because if I'm going to inspect them here, world info markings, the ones that I saved, we can see that there's no information here telling what type of marking this is. The type of object doesn't serialize in JavaScript. Yeah, I can tell that this is a traffic light and it was saved with the state of red. But yeah, it's just guesswork for many of these. Or this image, I can tell that it's the start because it's the only one that has an image. This has 2 borders, so might be a parking, or I don't know, crossing could be as well. So we actually need to store the type of these markings with the object as well as an attribute. And that means we have to open up these markings again and edit all of them and tell this one that this type is a crossing. Save. And this type is a light. And save. And this one, it's a marking that hasn't been inherited from and shouldn't really be used like this, but I will give it a type also for consistency. And then this is parking. And this is start. And this is a stop. This is target. And this is yield. And now if we go back here, we need to generate a world and save it with markings that have this type. So the original ones are lost forever, pretty much. Let's refresh and add new markings. I hope I remember where I put them before. These were the traffic lights, and I think I had the parking here. Maybe I had the crossing somewhere here. I don't really know. Car was starting here, I think. Let's put the stop. Let's put it here because this kind of looks like a priority lane. I think I'm happy with this. So let's save again and refresh. And the markings are not there. But now if we do look in the information that they have, the type is there. So I do know this thing with 2 borders, now it's a crossing. So we do have what we need to load them into memory as proper objects. I'm gonna close all of these open files now. And in world.js, let's write this world markings. We remap the information from the markings to marking load m, like so. And we have to implement this load method next. So inside of marking.js, here, static load the info, and here we have to do a switch based on that type that we now have. So switch info type, and just gonna take these in order from here. Case crossing, return new crossing, add the info center x, info center y. We have to create a new point, and this is the direction vector x, direction vector y, and the width and the height are like that. And I have to copy this for all of them pretty much, and it would be quite a lot of code here and many lines. So I'm gonna extract these 2 longer ones at the top. It's going to be the same for all of them. All of them have this center location and this direction vector. There for short, I'm just going to put this one here. And now here we can type point dir and width and height and close this in one line, which is much nicer, I think. And we can copy this 7 times. This is going to be now light, marking, parking, start, stop, target, and yield. Let's save and refresh. And there they are. Our markings are now here. Great. So this now works, but what if we want to store many scenarios, many worlds? We want to play with this and create a bunch of different worlds. I'm going to teach you how to store them as a file and then load them from the file that you stored them in. This is also going to help with memory problems if the world is too big and it doesn't fit in local storage. So here inside of this save, I'm going to go at the top and define an A tag, which we will artificially click to download a world file. Now the syntax for this I won't explain in too much detail, but basically we will use JSON here, so I am going to specify that we use application JSON and just in case UTF-8. And we encode this information like that, coming from the string of the current world object. Now here we generate the file name, and it's going to be name.world by default, but depending on your browser settings, you're maybe asked to enter the name when you save the file. And then here I'm going to set the attribute to download and pass this file name as well. And now we can trigger click, which is going to start the download. So when we press the save button, all this will happen and it will put the world information in a file called name.world, but you can change this name. Just the extension world is important. Let's now save and refresh. And let's save this world file. You probably don't see these screens here where I'm entering the name, but it did save somewhere on my computer. So this, I have a backup of it. And now let's remove it and try to have a new world, maybe different looking. Let's just use this kind of square shape and maybe give it a diagonal like so. And let's save this one as well. And I'm going to use a new name for that. And now when we refresh here, I am going to get the new one. The first one is lost basically, but we can get it back if we implement load functionality from a file. And I'm going to do that here below the save function. We are going to have another function called load. And this is going to be linked to file input. You'll see. We get the first file from there. And if there is no file, let's just give here a quick alert that you haven't selected anything. And return. We don't want to get to this part of the code here. So we begin to read the information from the file. And we read it as text. Then unload I'm going to pass this callback function here, give an event as the parameter. I will take the content of this file like this and parse it because it's a string by default. And now we can use this information to load a new world. So world is going to be load this new data. And what I'm going to do now to prevent reinitializing a bunch of objects is I'm going to set this information in local storage here and then reload the page. So basically this button is going to reload the page after it stored the world in the new local storage item here. But one thing we still need to do is this world needs to be reassigned to something else, and it's a const. So going back up here, I'm going to change this world into a let, and this should work. To call this function, we're going to need file input, and I'm going to put it here and give it also a label for this file input. And the class, I'm going to make it look like the other buttons in CSS. Otherwise, it's very ugly, I think. And I will use this emoji of a folder here. And the input itself, let's put it like this. The type will be file, and ID is this file input. It will accept files of type world. And on change, we call our load with the event information. Which file did we select? Now, if we save and refresh, we're going to see here some quite bad layout happening. But let's see if it works. So pressing this, it asks me to select a file, and I'm going to select the first one that I had previously. And I got it back. Great. Only thing now to style this to make it look like the other buttons. And I do that in styles CSS. I'm just going to reuse this style like so. And the default styles for these are a little bit different. I'm going to force both of them to have this inline block display. And I want to hide the contents of the file type input as well. So we just see that emoji there. Save, refresh, and now it looks like that. And when we refresh the page, we still have this world, but now I can change to the other one we created. And it's here. Every time we refresh, it's still this one until we change to another one. I'm now constantly selecting different files there, but you don't see those windows. My recorder doesn't catch them. One thing I would like when storing these worlds is also to keep the viewport information part of the world itself. Like, how should it be presented? Because here it doesn't show everything, and I always seem to zoom out like this. So maybe this world should look like this by default. We can do that by storing the viewport, zoom, and offset information part of the world itself. Let's go back to index.html in our save function. And here at the top, I'm going to do just that. World zoom is viewport zoom. World offset is viewport offset. And now let's save this, refresh, and put again this reference here, and now save again. I'm gonna overwrite the previous worlds. That's one, and the other one like this. So now they should have that information in them. But if we refresh, the viewport isn't adapting to it. So we have to do that and also make sure that the world is going to load that information from the info. So inside of world.js here, I'm going to also type world zoom comes from the info zoom, and world offset comes from info offset. And back in index.html, where we define our viewport here, let's pass it also the zoom and the offset of the world and handle it inside of viewport.js in the constructor. These will have some default values in case they don't exist. But otherwise here, let's just pass that, and the offset, this is fine if the offset is not specified. So I'm just going to say if there is an offset, set it to that offset. Otherwise, whatever we had previously. Save, refresh, and now we get this exactly as we wanted. And the other one works as well.